ballast kit for a metal halide lamp can sometimes cost more than an entire wall fixture, even one that includes a bulb. Here's why. Firstly, ballasts require specialized electronic components and sophisticated manufacturing processes. This makes them expensive to produce. Secondly, ballasts contain important safety features, such as thermal protection, surge protection, and ignition control. These features add to their complexity and therefore their cost. Thirdly, the market for M90 Metal Halide ballasts is relatively small. This limited demand results in lower production volumes, which drives up individual prices. Fourthly, ballasts are specifically designed for particular fixtures and bulbs. This limits their interchangeability and increases demand for specific models, raising their cost. Fifthly, ballasts often use premium materials, such as copper windings and high-grade capacitors. These enhance their durability and performance, but also increase their cost. Wall fixtures typically include a ballast as part of their overall design. However, the ballast in a complete wall fixture is often a low-cost component intended for general lighting applications. A ballast kit for an M90 100-watt metal halide is designed for high-intensity discharge lighting. HID lighting requires a dedicated and specialized ballast for optimal performance, efficiency, and longevity. The high cost of M90 Metal Halide ballast kits is justified by their specialized design, safety features, limited production volume, compatibility requirements, and premium materials. These factors make them essential components for achieving the desired performance and efficiency from HID lighting systems. Consider manufacturing costs involved in creating a ballast. The sophisticated electronic components needed mean specialized machinery and expertise are necessary, leading to higher production expenses. Think about the safety features engineered into ballasts. Components like thermal protection prevent overheating, surge protection guards against voltage spikes, and ignition control ensures safe lamp starting. These safety measures add to the overall complexity and cost. Look at the dynamics of supply and demand. The niche market for M90 Metal Halide ballast means a smaller customer base and fewer units produced compared to more common lighting components. This reduced production volume translates to higher prices per unit. Examine the importance of compatibility. Ballasts are not universal devices. They are designed to work with specific fixtures and bulbs, ensuring optimal performance and safety. This specialization limits interchangeability, increasing demand for specific models and driving up their cost. Delve into the quality of materials used. Ballasts often incorporate premium components like copper windings for efficient energy transfer and high-grade capacitors for reliable operation. These materials enhance the ballast's durability and performance, but also contribute to its higher price tag. Think about the differences between a general-purpose ballast in a standard wall fixture and a specialized metal halide ballast. Wall fixtures typically use lower-cost ballasts suitable for basic lighting needs. In contrast, metal halide systems, especially those using M90 100-watt lamps, demand high-performance ballasts engineered for the unique characteristics of HID lighting. These specialized ballasts are designed to provide the precise voltage, current, and waveform necessary for efficient and stable lamp operation. Without the correct ballast, a metal halide lamp can flicker, produce inconsistent light output, or even fail prematurely. The design of a metal halide ballast includes sophisticated circuitry to regulate the lamp's starting and running characteristics. Metal halide lamps require a high voltage pulse to initiate the arc, followed by carefully controlled current to maintain stable operation. The ballast must also compensate for changes in line voltage and lamp impedance to ensure consistent performance. Furthermore, metal halide ballasts often incorporate features such as power factor correction and harmonic filtering to minimize energy waste and reduce electrical noise. These features add to the complexity and cost of the ballast, but they also improve the overall efficiency and reliability of the lighting system. The materials used in a metal halide ballast are also chosen for their ability to withstand the high temperatures and electrical stresses associated with HID lighting. High-temperature insulation, robust capacitors, and durable magnetic cores are essential for ensuring long-term reliability. Consider the regulatory requirements that govern the design and manufacture of ballasts. Safety standards, energy efficiency regulations, and electromagnetic compatibility requirements all add to the cost of compliance. Manufacturers must invest in testing and certification to ensure that their ballasts meet these standards. All of these factors contribute to the higher cost of metal halide ballast kits. They are specialized components designed for demanding applications. While it may seem more economical to purchase a complete wall fixture, using the correct ballast is essential for achieving optimal performance, efficiency, and longevity from a metal halide lighting system. Furthermore, using the wrong ballast can create safety hazards such as overheating, electrical arcing, and premature lamp failure. This specialized design, safety features, limited production volume, compatibility requirements, and premium materials justify the higher price. These factors make them essential components for achieving the desired performance and efficiency from HID lighting systems. Understanding the intricate workings of a metal halide ballast reveals the justification for its cost. It's not merely an electrical component, it's an engineered system optimized for a specific type of lighting technology. The high-voltage ignition circuitry, for example, is a critical element. Metal halide lamps require a significant voltage spike to initiate the arc discharge within the bulb. The ballast generates this spike, often several thousand volts, to ionize the gas mixture inside the lamp. Without this initial jolt, the lamp simply won't light. The current regulation circuitry is equally important. Once the arc is established, the ballast must precisely control the current flowing through the lamp. Too much current can lead to overheating and premature failure, while too little current can cause the lamp to flicker or produce dim light. The ballast uses sophisticated electronic components such as inductors, capacitors, and semiconductors to maintain the current at the optimal level. The power factor correction circuitry is another key feature. Metal halide lamps have a lagging power factor, which means that the current waveform is out of sync with the voltage waveform. This can lead to inefficient energy use and increased electrical losses. The ballast incorporates power factor correction circuitry to bring the current and voltage waveforms back into alignment, improving energy efficiency and reducing electrical noise. The thermal management system is also crucial for ballast longevity. Ballasts generate heat as they operate, and excessive heat can damage the electronic components and shorten the ballast's lifespan. The ballast design includes heat sinks, ventilation openings, and sometimes even cooling fans to dissipate heat and maintain a safe operating temperature. These design elements add to the complexity and cost of the ballast, but they are essential for ensuring reliable performance and long life. Consider the testing and certification processes that ballasts undergo. Manufacturers must subject their ballasts to rigorous testing to ensure that they meet safety standards, energy efficiency regulations, and electromagnetic compatibility requirements. This testing involves specialized equipment and skilled technicians, adding to the overall cost of development and production. The specialized nature of metal halide ballasts also contributes to their higher price. Unlike more common lighting components, such as incandescent or fluorescent ballasts, metal halide ballasts are designed for a specific type of lamp with unique electrical characteristics. This limits the interchangeability of ballasts and increases the demand for specific models, driving up their cost. Furthermore, the limited production volume of metal halide ballast means that manufacturers cannot achieve the same economies of scale as they do with more common lighting components. This lack of scale also contributes to the higher price. The choice of materials also plays a significant role in the cost of metal halide ballasts. Manufacturers often use premium materials such as copper windings, high-grade capacitors, and heat-resistant plastics to ensure durability and reliability. These materials are more expensive than their lower-quality alternatives, but they are essential for withstanding the demanding conditions inside a ballast. In conclusion, the high cost of metal halide ballast kits is justified by a combination of factors, including specialized design, safety features, limited production volume, compatibility requirements, and premium materials. These factors make them essential components for achieving the desired performance and efficiency from metal halide lighting systems. When comparing the cost of a ballast kit to the cost of an entire wall fixture with a bulb, it's important to consider the intended application. Wall fixtures are often designed for general lighting purposes, while metal halide lamps are typically used for more demanding applications such as street lighting, stadium lighting, and retail displays. The higher cost of metal halide lighting systems reflects their superior performance, efficiency, and longevity. While it may be tempting to save money by using a low-cost ballast or fixture, this can ultimately lead to higher costs in the long run. Using the wrong ballast can damage the lamp, reduce its lifespan, and decrease its light output. It can also create safety hazards such as overheating, electrical arcing, and premature lamp failure. Investing in a high-quality metal halide ballast kit is a smart choice for anyone who wants to achieve optimal performance, efficiency, and safety from their lighting system. The initial cost may be higher, but the long-term benefits outweigh the short-term savings. The engineering that goes into designing a reliable and efficient ballast is substantial. Consider the precision required in winding the transformer coils. The number of turns, the wire gauge, and the insulation material must all be carefully controlled to ensure optimal performance and minimize losses. The selection of capacitors is also critical. The capacitors must be able to withstand high voltages and currents, as well as high temperatures. They must also have a low equivalent series resistance to minimize energy losses. The semiconductors used in the ballast must be able to switch quickly and efficiently. They must also be able to withstand high voltages and currents without failing. The design of the printed circuit board is also important. The traces must be wide enough to carry the high currents without overheating, and the components must be placed in a way that minimizes electromagnetic interference. The mechanical design of the ballast is also crucial. The enclosure must be strong enough to protect the components from damage, and it must be designed to dissipate heat effectively. The ballast must also be able to withstand vibration and shock. All of these design considerations add to the complexity and cost of the ballast. However, they are essential for ensuring that the ballast is reliable, efficient, and safe. The manufacturing process for ballast is also complex and demanding. The components must be assembled accurately and precisely, and the assembly process must be carefully controlled to ensure that the ballast meets its performance specifications. The ballast must also be tested thoroughly to ensure that it is working properly. The testing process typically involves measuring the voltage, current, power, and light output of the lamp. The ballast is also subjected to a variety of stress tests to ensure that it can withstand high temperatures, vibration, and shock. Only ballasts that pass all of these tests are shipped to customers. The quality control process for ballasts is also rigorous. Manufacturers typically use statistical process control techniques to monitor the manufacturing process and identify potential problems. They also conduct regular audits of their suppliers to ensure that they are meeting the quality standards. All of these quality control measures add to the cost of the ballast, but they are essential for ensuring that customers receive a reliable and high-quality product. The cost of research and development also contributes to the price of ballasts. Manufacturers invest heavily in research and development to improve the performance, efficiency, and reliability of their products. They also conduct research to develop new types of ballasts that can be used with new types of lamps. This research and development is expensive, but it is essential for ensuring that the lighting industry continues to innovate and improve. In summary, the high cost of metal halide ballast kits is justified by a combination of factors, including specialized design, safety features, limited production volume, compatibility requirements, premium materials, rigorous testing, quality control, and research and development. These factors make them essential components for achieving the desired performance and efficiency from metal halide lighting systems. When considering the total cost of ownership of a lighting system, it's important to factor in the cost of the ballast. While the initial cost of the ballast may seem high, it is a small fraction of the total cost of the lighting system over its lifespan. The ballast is responsible for providing the power to the lamp, and it plays a critical role in determining the lamp's lifespan, light output, and energy efficiency. Using a high-quality ballast can significantly reduce the total cost of ownership of a lighting system by extending the lamp's lifespan, increasing its light output, and reducing its energy consumption. In addition to the direct costs of the ballast, there are also indirect costs to consider. Using a low-quality ballast can lead to premature lamp failure, which can result in downtime and lost productivity. It can also increase the risk of safety hazards such as electrical shocks and fires. Investing in a high-quality ballast can help to avoid these indirect costs and ensure that the lighting system operates safely and reliably. Metal halide lamps are more efficient than many other types of lamps, so they can save energy and reduce electricity bills. However, they require a ballast to operate, and the ballast consumes some energy itself. The efficiency of the ballast is an important factor in determining the overall energy efficiency of the lighting system. High-efficiency ballasts consume less energy than low-efficiency ballasts, so they can save energy and reduce electricity bills. Some ballasts also have features such as dimming and occupancy sensing, which can further reduce energy consumption.